Who am I? So I'm Ruggero. I'm a tech lead at Docebo. I've been working with software for 10 years almost, and with serverless specifically for the past 5 years. Today, I want to share with you some, let's say, hopefully, words of wisdom that derive from my and the different teams I've been working with experience throughout these 5 years. You can find rants about software engineering on different, let's say, places, LinkedIn, Substack. I have a blog of mine. Sessionize, you can see what I've been talking about for the past 2 years, and GitHub if you are interested in some pet projects I've been working on. Each links kind of cross-references the other, so feel free to just take one and you can follow me. Okay, so let's start by clarifying some glossarying and terms. So I'll use manage to refer to services that are basically platform as a services platform as a service services with no runtime code managed by the team that are in this case provided by AWS. I will talk about serverless compute to refer specifically to Lambda, Fargates, and similar. I will talk about serverful for those, let's say, infrastructure as a service. So when you have to run basically an EC2 machine or similar, and you have to manage the servers as well. And then containerized, it's just to create a clear distinction between serverless, where you don't have to manage the, let's say, containers or the image, and serverless like Fargate, where you might have to. Some context, I've worked mainly with serverless, AWS, managed and serverless compute, CDK CloudFormation. I'm worked in 2 different DevOps teams, meaning teams that own end-to-end the whole life cycle of the software, fully autonomous. And in the last team I've been working on, we usually do many deployments a day, 3 to 4 deployments a day. So we do continuous delivery by its true meaning. So some reasons, I'm gonna be quick on this part because the interesting part comes later and we don't have a lot of time. So some reason to choose for why you might want to choose serverless: time to market, lower operational cost and complexity compared to having to maintain your own infrastructure, pay-per-use model. This might be an advantage as well, and we'll see later also a disadvantage in some case. And then it can scale usually higher than most people think when you got it right. And it gives you a lot of autonomy because you don't need to start with necessarily an infra team or a platform team, because AWS in this case, but any cloud provider that provides serverless stuff does do that for you. Wrong reasons, I've been heard talking to different teams throughout these 5 years why they choose serverless. So mainly because you don't know or maintain any infra. This is not a good reason why to choose serverless, because you indeed will maintain something. We might not call it infra, but still there's maintenance to do, which is not only the runtime code. Less testing needed, not true, just different testing needed, as we'll see. And just deploy it, it scales automatically. That turns out to be a big mistake when traffic goes up. So I want to provide a bit of an overview. This is not like a precise graph or statistical thing, but it's just one kind of an overview where I want to provide an overview of where you might want to be in the scale depending on what you need. So if you need more control, but you're also willing to accept a longer time to market, you might want to move to the upper right corner. If you want less, if you accept less control, but you want a fast time to market, usually managed and serverless services are a good fit. In the middle, we have containerized solutions. So for example, Fargate again. And then again, in the upper right corner, you get the most of the control, but also the most of the complexity and maintenance required. Then sometimes using serverless functions is quicker than integrating different managed services together. And there is a third variable that, let's say, later in your journey, you'll discover it becomes important, which is the bill, which is basically in the lower left corner. So yeah, less time to market, but then when the traffic goes up, usually greater bill. When you get more control and you move to servers pool, you get to optimize a lot more your infrastructure and therefore lower your costs. So this is an average serverless developer at the start of that journey, right? They say, yeah, let's go and let's do camping. I want to start my survivalist journey. And they end up like this. I hope by the end of this presentation, you feel more like this. So able to thrive and survive in the serverless, let's say, environment. So development blueprint, very quickly, we'll go through each of these topics, continuous delivery, the whole set of practices, a condensed, let's say, version for serverless developers, testing strategy, so what kind of testing strategy you need to thrive in a serverless environment, no downtime policy, what does it mean, how do you enforce a no downtime policy, cost management, this is a good one that is often overlooked and turns out to be a nightmare, especially for your employee probably who has to pay them the bills. And get good at architecting, because you have by having a lot of control, you get also a lot of responsibility. And now architecture is mostly your work and not somebody else. Continuous delivery. So deploy small changes often, which means multiple times a day, even like 20 lines of code, deploy as often as you can, and make sure to make the way to production very smooth in order to do so. Use ephemeral environments to shift left feedback. So use environment that can be created and disposed very quickly, and allow developers, make sure that developers can use these environments as left as possible in the feedback loop, ideally even from local machines, but also in your pipeline, maybe during code reviews and what have you. Always have a rollback strategy, so don't forget it. Yeah, we all want to deploy new code, but what happens if the code that we deployed doesn't work as expected and we need a quick way to roll back? So think about that and make it easier to roll back, but favor fixing forward when you can, especially if you work with CloudFormation. That's usually the best strategy. Testing strategy. So I want to start saying that you cannot have cloud services on your machine. But cloud services become part of your business logic. So what we do now to make sure that everything works as expected in production. And throughout the years, I heard, I test only the runtime code and then I mock everything else. Or I mock cloud services specifically, for example, local stack or similar things. I test manually in dedicated AMPs, so I deploy in those AMPs and make sure that everything is there up and running. Or again, local stack, which is basically another way to mock things locally, but you just don't have to maintain. And then a casual Friday deployment later. You deploy something, everything is broken, and the customer wants to kill you, rightfully so. So what do we do to turn this testing strategy into an effective testing strategy? And I want to ask a question. Where do cloud services really behave like cloud services? And the answer, I think it's simple, and it is in the cloud. So an effective testing strategy for serverless developers is to switch from a test pyramid to a prisma, where you do all those checks that you can do against the static code, which means dependencies check, licenses, code quality, secret detection, and more. But then you also do snapshot and unit testing on the SaaS and infrastructure as code part of your code base. Also, you hopefully do unit tests and SaaS for the runtime as well. But the really important part is to do integration and dust and fast testing and you name it against deployed services that really behaves like production, so a kind of pre-production environment, or if you are good enough, also a real production instance by doing dark deployments, A/B deployments, and using these techniques, so testing in production. And then acceptance tests against the whole integrated team system, so again, deployed on the cloud and not on your machine. And then, very important, production observability, so be able to tell what's going on in production, having monitoring alarms, and also design, as we'll see later, those monitoring alarms during architecture design, so understand what you want to observe when you architect new things. No downtime policy. We can use a maintenance window. That's another common phrase that I heard very often when teams find themselves having to introduce breaking changes or having to do changes that requires to remove resources. So they often say, yeah, we can use a maintenance window, nobody will care. And that's still the customer when you present them with the impossibility of using your service, because they're paying for your service, and most of customers nowadays expect your services to be up and running all the time. So no downtime policy. It starts by having a deployment plan. So when you architect new stuff, think about how you want to deploy it. If you need to break down in many different end steps deployment and bring each one to production individually and make sure that it does what you design it to do, and then validate each one. So make sure the monitoring is not, let's say, producing alarms. Make sure that it is doing what you design it to do. Make sure that it scales up to the volume that you need it to scale up. And then another good strategy is to, when you have to switch and introduce breaking change, is always add new stuff, deploy it there in production, and then do the switch, make sure everything works. Once you did the switch, everything works, and you're happy, then it's time to remove the old stuff. That allows you to go back anytime if something is wrong, let's say up until to the first step, of course. So you can create new stuff. Okay, something is wrong with the deployment. No worries, we are still on the old stuff. There's no issue. Create goes green, so create is fine. And now you have to do the switch. Something goes wrong. Okay, no issue. We can switch back to the old one. The third one shouldn't be an issue anymore, because your traffic is already on the, let's say, new infrastructure, and you don't have to worry about a deletion going bad or something wrong happening. And then avoid having a policy and strictly adhere to a policy that avoids maintenance windows at all costs, because this, let's say, thinking exercise forces you to consider all of the three previous steps. If you start lazily saying, okay, we can use a maintenance window, and 99.9999% of the cases that's not true, you don't need that, you will always fail to use the previous steps as guidance. Cost management. This is another great debate among the serverless community. So very often we hear about disasters with using serverless, companies that almost go bankrupt because of their serverless implementation. And I often wonder, okay, how can we prevent it? And what can we do to make sure that this doesn't happen? Like with many other things in software development, right? We have many dimensions that we need to consider, and costs is one of those dimensions. So one day you're there, your app is online, you went viral, and you're very happy. But then the month after, you look at the AWS bill, and this is you, especially relatable for Italian people, looking at the AWS bill with this gigantic spike, and then the step after is how am I gonna pay this, right? So how do we prevent this? Monitor costs, first of all. So as with always, be aware of what's happening. Have alarms for cost as well. Know when the costs become too much for your, let's say, appetite. Set budgets as needed. So you might have services that are not business critical that you are fine, turning down if they become too costly for you, because at the end of the day, we want to be 24/7 online, but if you go bankrupt, you cannot be anymore. So maybe at some point you want to set some budget, especially in development environments. Most of the time, the environments that end up costing a lot are the development environments. It's not even production. And then set services limits. Why setting services limits? Because it allows you, if you also architect for failure, to basically distribute traffic more evenly and therefore avoiding those spikes, because serverless can scale, as I said initially, serverless can scale higher than many people think. And most of the time, what company discover is that serverless can scale higher than their capacity to pay for it. So make sure that you are setting limits so that serverless don't scale higher than what you can afford. And then you want to move to your load to containerized and serverful when convenient. So once you identify your stable volume, or you are successful, you can pay more people and you can start building up your software engineering department, you can start building your platform, you can do many things, you can do hybrid between serverful and serverless. So it's not like you need to stay on the serverless. Serverless is a great way to start. It's probably at some point something that you want to move away from, at least partially. And another important bit most of the company and also the software engineers don't take into account is to architect for the business model or design the business model based on the infrastructure. So your business model has to take into account the costs derived from your infrastructure. For example, like if I'm YouTube and my infrastructure costs a lot when people consume my videos, and I say, okay, I'll make money by making people pay once in their lifetime, I'm not probably gonna stay around for a lot of time. The other way around, if my company decides that they want to sell with a business model of pay once in a lifetime, I might have to find a different solution that's serverless, because I'm gonna pay per use, and those two dimensions don't go very well with each other. And then last point in this blueprint is to get good at architecting. So what does that mean? I read Grigor Hopi software architect elevator book, and I think the most inspiring piece of the book is when he challenges to think about architectural component before picking up the service that I want to use, or even the technology. And that's even more true with serverless. We are presented very often with example and patterns that already steer us towards certain serverless services. But in reality, what we should do as architects, because when we work with serverless, we are also, let's say, wearing the architect cap, is think about the architectural component that we need, think about the target architecture that we need to develop, and only after pick the services that better suits our vision. And what I often saw is quite the opposite. People choose services that they know very well, or choose services that they have been suggested by patterns, and they forget about the architecture that they need to implement. So they either end up implementing, let's say, way too complex architecture for what they have to do, or they miss the target entirely and implement naive architecture that don't resist production. Then other aspects that are very important are data flows. So make sure you understand how the data flows in your system very well. Make sure you track very often through many architectural decision records why you decided to implement certain architecture. What was the context? what was also the business scenario, what were the constraints, who were the team members, because that is also another key components of making decisions. And then make sure to design for realities, so scalability, testability, profitability. So make sure to consider all of those things, because when you work with serverless, you are not only developing the runtime anymore, you are also having a huge impact on your organization, your team, and the overall ability to thrive. And then design for failure. So this is something that we often forget about. We design for the happy path, and we think that the distributed nature of the web and the internet will have mercy on us, but that's not true. So always design for failure. Always make sure that your services resist, for example, other services going down, and they stays up, or they don't end up in those circuit, and which turns out to be the biggest cause of financial disasters. So always make sure that your services are stay up and down and keep working and have fallbacks even when the rest fails around them. So wrap up before welcoming questions. If you want to thrive in a serverless development environment, you have to do frequent baby steps. And when I say baby steps, I mean baby steps. Even 2 lines of code, put them in production, see what happens. Don't be afraid of going in production with very little. Rethink testing strategy. You cannot test anymore on your machine only. You cannot do only unit tests anymore. You need to test mainly on an integrated environment and make sure that the services work with each other the way you designed them to do. Share ownership across the whole team. Like, this is an anti-pattern that I often saw and still see in many teams, where there is an infrastructure specialist that don't share their knowledge, or even worse, there are people in the team that own a specific services and the rest of the team don't have a clue of what the service does. So share ownership. All the team needs to participate, be aware, make decisions, and feel confident about the services that the team owns. Avoid any downtime, including maintenance window. So design everything that you do to avoid the downtime. Even if it gets longer, you need more steps to reach your goal. Your customers will thank you. Your team will thank you as well when they don't have to go on call because you deploy something, let's say, naive. Manage costs. You have now a lot of responsibility. The business trusts you with those tools. Make sure you don't end up making your business going bankrupt, which means you also lose a job and you have to look for somebody else, and also probably not a good, let's say, thing to have on your curriculum. And then everything fails all the time. So when you design stuff, imply that it will fail badly, it will fail in ways that you didn't even think of. So make sure that you are ready by having observability, by designing for failures that you don't know exist, and having a plan to quickly bring up your service again. Okay, so additional resources. There are a bunch of additional resources. Some are articles of mine on the same topic. They go a little bit more in depth on some things that I shared here with you. For example, ephemeral environment, how you can leverage them, a way to also implement them with serverless, continuous delivery in practice. There's an article. There's also somewhere around my contribution to the Working Code Conference 2023, where I share how me and the team implemented continuous delivery. Then a couple of articles from AWS on how to test serverless functions and how to test serverless application. Spoiler, they basically say test the most that you can on the cloud. And then managing costs, practicing continuous integration, and architect elevator blog, which is a kind of, it is a gem for any software engineer or architect around by Grigor Hopi, which was a huge contributor in AWS for the past 5 years almost, I think, before leaving, unfortunately, in the also in the serverless, I think, division, if I'm not mistaken. So make sure to check it out. Question?